Okay, so let's review parabolas a little bit. We only talked about it one time, and I feel like we need to spend a little more time on this. So the standard form for a parabola, well, this is the version for a parabola that opens upward, right? Remember, this is the picture that we looked at last time, right? Parabola is just the locus of points equidistant from a line that we call the directrix and a point that we call the focus, right? So the distance to any point on the parabola is always going to be the same to the focus and to the directrix. All right, so this is, like I say, this is the version that opens up. We could also look at one. We could look at a parabola that has a horizontal axis that opens sideways. And all we would do is just trade the positions of the x and the h and the y and the k. We'll look at one of those later. So the part that I'm guessing people probably are having a little bit of an issue with is, I would think, is what is P, right? So the vertex of the parabola is the point, thank you, is the point that is equidistant, it's on the parabola, so it still has to be equidistant from the focus and the directrix. And it's the point that's positioned exactly in that segment, halfway in between, right? And so if we knew, typically, with a lot of like the first problems you get, you're given, for example, the vertex, right? You're given the coordinates of the vertex, or you're given the coordinates of the focus and the directrix, and you're asked to find this equation, right? And so what you would have to do then, if you're given the coordinates of the focus and you're given the equation of the directrix, you would have to find, like in this case, you'd have to find the middle y value, right? And that's going to be the y value of the vertex. And then they're going to share, it's going to have the same h value, x value, right? The vertex, the value of h is the same for both the focus and the vertex, right? We'll look at an example in a second. But P is this distance. And it's also this distance. So the distance from the focus to the directrix then is just 2P. Okay? That's the picture that we've got to be thinking about when we do these problems. So let's look at an example. We may come back to this picture. But here's an example of the kind of problem that you see, something like this. Right, the simplified standard form equation of the parabola with a focus here and a directrix there, right? Okay, so if you want to, I don't think you're going to need to do this very often at least, but at least initially, maybe you want to even just do a sketch to kind of orient yourself a little bit, right? So if this is the xy plane, we've got the line, the directrix is the line, x equals 9. And the focus is the point over 7 and down 3. So something like right there. So just visually, where is the vertex going to have to be? This is the focus, right? Where's the vertex going to have to be? Say again, Kirk? Yeah, it's going to be 8, negative 3, isn't it? You can see it's going to have to go, it has to be halfway in between, right? Does that make sense? It's always halfway in between. And then the parabola is going to open to the left or the right? To the left. Like that, right? We know that this distance has to be the same as that distance. That's P, isn't it? Right? Yeah. So the coordinates of this point between 7 and 9 is 8, and it's got to share the same y coordinate as the focus, right? Because they're going to line up horizontally. So that's the vertex. And we can see then that the value 2P is equal to the difference between the x values of the focus and the directrix, right? 2P equals 2. So P equals 1. That's all I need, right? I can take that information and go, let's see, let me grab this one. do is just plug it into there, right? So I've got the sideways version. Oh, actually, one thing. We gotta amend this very slightly. The value of P is 1, but there's one other part of this I forgot to mention. P is going to be the amount that you're going to travel from the vertex to the focus, right? And so in this case, we're starting at a value K that would be, let's for example say it's 4, and we're going to end up at a value that's going to be like 6. So we're moving upwards by 2, so P is positive, right? If this parabola had been inverted and was turning down, we would have started at the vertex and had to move in the negative direction to get to the focus, right? So as a general rule, we always say then that P is going to be positive for parabolas that open in the positive direction. So for a vertical parabola, up is positive. For a sideways parabola, right is positive, right? So then, what about this one? It's going to be negative, isn't it, right? The absolute value of P, the length of that segment is 1, but because we're starting at the vertex and having to go left, we're going in the negative direction. So P becomes negative 1. Okay? So then all we've got to do is just plug this information. Here's H and K. And there's P. Plug them in and we're done. That's it. Right? We really just have to determine what's the value of this and where's the vertex. Okay? Try one. Try that one.
Triggered it.
Okay, what do you think? What do you think? So, if you just, once again, you may end up not need to do this, but if we just were to maybe sketch this out real quick, y equals 7 is the directrix, and the focus is at 7,3, right? So there's the point. 7, 3. So focus has to, or the vertex has to be halfway in between, right? So here's the vertex. And so what do you think, Ruby? What's going to be what are the coordinates of the vertex going to be then?
I have no clue. Wouldn't it be
7, 5, yeah, right? Because the directrix is a horizontal line, right? Does that make sense? And so it's the y values that are going to be changing here, right? So this line has, every point has a y value of 7. The focus has a y value of 3, and so it's got to have the intermediate y value, doesn't it, the vertex? So that's going to be 5. Oops, and what's the x value going to be? Yeah, it's going to have to line up with this point vertically, isn't it? So it's going to be 7, right? And once you've done a few of these, you don't even have to draw the picture, right? You'll recognize that, okay, that's going to be that's a y value, isn't it? It's a horizontal line. So I'm just going to compare that to the y value of the focus and take the intermediate value, right? So then what's k going to be here? That's k, right? I mean p, sorry, what is it, k? Thinking of physics. P. What's the value of p going to be? -2. How come negative? It's going down. Good, because the trip from the vertex to the focus is in the negative direction, right? So we get p equals -2, and this is the version that we want, isn't it, for a vertical parabola, right? How can you remember that? Somebody want to, if we've got these two versions, horizontal and vertical, how do you know which one's which? How could you, just what's a quick mnemonic device? How could you just trigger real quick, remember which one goes with a vertical parabola that has a vertical axis, opens up vertically, or down vertically? And which one opens up sideways? What do you think, Tyler?
The one that's horizontal is alphabetical, vertical is counter-alphabetical.
Oh, okay. I guess okay, that would work, I suppose. Any other ideas?
Make a song.
Make a song. You can always make a song. Here's how I do it. What's the simplest? If you think parabola, what parabola are you thinking? Parent, like what parent parabola do you always think of? What is it?
X squared.
Y equals x squared, right? So if y equals x squared is just that parabola, right? Which one does that fit? Yeah, it's got to fit this one, doesn't it? Because the x is being squared and the y is not, right? Make sense? Okay. All right. So does that make sense then? We could finish that, but all we're really doing is just plugging in values, right? Yeah.
So what if p had a value of 0? Like the point was on the direction.
Okay, so if p had a value of 0, then it wouldn't really make sense as a parabola, would it? Think what the definition of a parabola is. The definition of a parabola is it's the locus of points equidistant from the focus and the directrix, right? And so what points would be equidistant from the focus and the directrix in that case? It'd just be it wouldn't make any sense, would it? Right? Because if the focus is on the directrix, then the distance between the two is 0, right? Okay, so that's the point where parabolas would cease to really have any meaning, right? What would happen is if we migrated, in fact, that's a good question. Give me just a second because I want to answer that. I got an idea how I could show you this. Okay. So this is what I'm talking about. Let's see. So there's the locus of points, right? A is the focus, and I'm sliding B along the directrix. C is just a representative point on the parabola. Okay, watch what happens if I drag this point down. I think I can do this. See what's happening? If it actually, yeah, when it goes to there, look what happens. It doesn't. It approaches an infinitely skinny parabola, but then when we get to the actual, when it jumps onto the directrix, it doesn't make sense anymore, right? There is no locus of points anymore, right? Further I go away, what's the, in math or physics we call it the envelope of the parabola. What's it going to do, the shape of the parabola, just descriptively, as the focus approaches a distance of infinitely far away from the directrix? What's the parabola going to start to look like? Yeah, it's going to start to look like a line, isn't it? Right. Okay.
It's like the closer you get to your album.
That would be a real interesting, for a later day, that would be a real interesting discussion to have, is how you could show that, because there's some pretty cool things that would come out of that discussion. All right. Okay, so moving on. How about something like this? Oops. What about that? We want to convert the equation to standard form. What's that going to look like? How are we going to do that? Yeah, it ought to look pretty similar to the stuff we did last time. I think we looked at an example, but let's look at another one. It's been a couple days. So this is going to fit which form? Left or right? It's going to fit the right, isn't it? Because the y is being squared and the x is not, correct? So we got to make it look like that. So what's our strategy then? If we want to make it look like this guy up here, how are we going to position the terms in this? We're going to obviously have to complete a square there, aren't we? So we're going to have to get a perfect square out of this, right? So how are we going to get that part?
Oh, okay.
How are we going to get that part?
Use the y's.
Okay, we're going to use the y's. So let's collect all the y terms on the left side, right? So we end up with y squared minus 14y, leave a space, right, because I'm completing the square. And then on the other side, we just want to get all the stuff that's going to build that, right? So equals, and then we'll push this stuff over to the other side. So that's going to give us a 4x minus 57.
So does there always only have to be like, in that case, it's like, so there's only ever gonna be one thing getting like, in parentheses getting squared.
In a parabola, yeah, in a parabola that's true. Remember, in a circle that wasn't the case. In a circle, this looked a little different, right? Circle, we had, what was the standard form for a circle? Equals r squared, right. So in a circle, they both work. But in a parabola, only one does. Okay? All right, now what? Okay, good. So I want to build a perfect square on the left side. So that's going to be what? Which means, what do I have to add to both sides? Okay, so then what do we end up with? On this side, that gives us 4x minus 57 plus 49 is minus 8. Agree? Okay, so what am I going to have to do to the left side to make it look like this up here? Divide by 4, because look, I've got to have, in the parentheses, I've got to have x by itself, right? So that means I've got to factor out this 4, don't I? Right? So when we say divide by 4, what we're really probably implying is we're going to factor out a 4. So this is going to give us then 4 times what's going to be left over. And we got it, right? Oops. Make sense? That's in standard form. So what's P?
1.
Yeah. Alright. About. So then how would I do, we don't need to spend time maybe doing this, but just tell me, how would I do a problem like that if I want to either graph or choose the graph of that parabola? What would I have to do to this equation right here? Yeah, I just got to put it in standard form, don't I? If I put it in standard form, then I'll be able to see by inspection. That's what we say in that. By inspection, we can say, okay, we can see that K is 7, H is 2, and 4 divided by 4 is going to be 1, which is P, right? So it's going to open up because P is positive. Does that make sense? This one would, and that's where the vertex is, right? Okay, so where do we recognize? Some of these get a little bit tricky. I would need to know, let's just do one of these, how about? I'm going to pick a harder one, though. I don't want to do those boring, easy ones. Oh, you know what? Something didn't work on that. Oh, yeah, it did. Never mind. Yeah, it did. Fine. Yeah, I did. There, that's what I want. Okay, this one, I just built these. I guess this one right here. You guys haven't started this one yet, probably. Not many have. I'll go in and fix that. There's just a missing sign there. I'll go in, and then if you just refresh it, it'll show up.
Wait, where are the little focuses?
I didn't give them to you on that one.
Oh, why not?
Yeah. Okay.
How are we supposed to solve it then?
Because on that one, you
Oh,
can
wait.
tell because of where the vertex is
Okay,
and which way it opens. But these are actually kind of tough because I set these up so there would be some distractors, some wrong ones that look almost the same, but just P is different, right? So how are we gonna? Let's do this one real quick. What are we gonna do here? Okay, so we get the x's on one side, right? So we're gonna have x squared plus 10x space equals, push this other stuff to the other side, right? 4y minus 29. You can already tell what's P going to be.
1.
It's going to be 1, isn't it? Yep. Okay, so what goes there? 5. So what's the value of H? What is it? No. -5. Yeah, because it's x minus H, right? So what do I add to both sides? So then we end up with 4y minus 4, which is the same as, if I factor a 4 out, 4 times y minus 1. So the vertex is at where? -5, 1, and P is +1. So let's see which one fits that. Let's just write that one over here. So vertex okay, which way is this going to turn? Open up or down? Up. Okay, so that's not it, is it? It's open the wrong way.
No.
No.
No. No. No. No. Yeah.
That looks pretty good, doesn't it?
Sure does.
There's our vertex at -5, 1. P is 1. Right? Does that make sense?
Yeah.
Okay? All right. So then there's some other questions on here. The second
What
one.
is the center?
What's that?
What would it be the center?
No.
No, HK is the vertex,
Okay.
not the focus, right? Okay, so
Oh,
how
well.
about these? Oops, not those.
Wait. You said
How about those? Okay, these are no big deal, right? I'm not going to really go through a ton of these for you. I want you guys to, this is where I'm going to make you kind of do some scratching your head and thinking about this. But all these are, you're just looking at, when they talk about like the cross section of a parabolic dish, it's just that parabola, right? So what are the coordinates of h and k, conveniently? If that's the equation. 0, 0, right? So that makes sense. When you set up an equation like this, where you're going to model something like a satellite dish or the cable on a bridge or something like that, with a parabola, you always want to set it up using coordinate geometry. We can set it up and we can put the vertex wherever we want to, right? So we put it in the most convenient place, which is at the origin, right? And so really all this is then is just you've got this, this model of this parabola centered at the origin. There is one thing about this that's, I'll just remind you about, that's a little bit inconvenient. Does that look like the proper way that the standard form? If the x is what's being squared, right? What was our standard form again?
X.
X minus
H.
h squared equals 4p times y minus k, right? Okay, so really if h and k are 0, that just becomes x squared equals 4py, right? So look what they've done here. This isn't really written in standard form yet, is it? What would I have to do to this? Multiply by 15, yeah, right? If I wanted to find out what p was. Okay, make sense? And then you're just going to use that model to answer this. They just want to know where the focus is.
So
Right.
what is the focus?
The focus, and this is kind of interesting. If you look at like lenses, and we're gonna in my physics class we'll talk about this stuff later. Here's what the focus does on a mirror, for example. If this is a parabolic, so let's say you've got this piece of glass, and you hollow out this parabolic shape, right? And then you just spray silver on it, right? You silver it to make it reflective. This is really just a piece of a larger parabola, right? And if I wanted to look at this in terms of a directrix and a focus, well, here's the vertex of my parabola, right? And the focus would just be some point out there, and the directrix would be some line back there, right? If we're looking at the cross section. Okay, so what do you think the parabola does? What do you think that focus does physically on the parabola? Yeah. Yeah, when light comes in, when parallel rays of light come in. So here's, it'll be green light. How about? So here's the green light coming in. It's coming in parallel. And light coming in parallel would be coming in from a long ways away, right? So if you want to, when you want to communicate with satellites, for example, right? They're so far away that when you send a signal, light signal, whether it's visible light or if it's infrared light or if it's microwave radiation, doesn't matter, it's all just light. If you send that out to the satellite, it's so far away that there's really no, think about like a flashlight dispersing. Well, by the time the rays get to that satellite, the only rays that hit the satellite are the ones that are coming in parallel, right? Does that make sense? Because it's so far away. So all these rays that come in parallel, they get bounced back through the focus. We call it focal point for a lens or a mirror, right? So every single one of these goes through that point. So what do you always notice about satellite dishes? They're parabolic, but really most of the dish is just the reflector. The actual receiver, the antenna, is where? Yeah, they call it a dongle. It just sits right out here. Usually there's some kind of a structure that just holds this one little receiver out in the middle, and it's at the focal point. It's at the focus of the parabolic dish. So everything gets focused through that one point. Now, if you want to send a signal accurately really far away, what do you suppose you do? Well, you could use a laser. But if you want to send, like, let's say you want to send a microwave signal, you can use a dish to send information too. How would you send all this information? If you just send it out, if you just like beam it out there every place though, the signal is going to disperse spherically and it gets weak really fast. You want to be able to send what's called a collimated beam. You want to send the beam parallel. So where would you actually point all the intensity of this? You know, when you're going to shoot out all these microwaves, where do you really want to direct them? Towards this, right? You're just going to shoot them off in this direction everywhere, and they're just going to retrace the steps, right? If they start at the focus, then when they hit the dish, they're all going to get reflected out parallel, and so you've got this really tight collimated beam that can communicate with another satellite dish, right? There's very little dispersion. There's a little bit of dispersion, but not very much, okay? And there's a similar, you can look at lenses, and lenses do something similar, but it's easier to see with mirrors. Okay, so you guys can just kind of wrestle with those a little bit. There's one here, I think there's one I built that's, yeah, this one, you got to draw a picture on this one, but I'm not going to help you with it. You guys can, you can just figure it out. Draw a little, oh yeah, I'm sure. Alrighty, so the last thing I wanted to show you, and just because I think we're not going to have school the rest of the week, I want to just take a quick look at this.
Do you?
I think today's going to be I have a feeling it's going to get bad. I mean, they're talking about some places, they don't know where, but there's going to be pockets that are supposed to get like 19 or 20 inches in eastern Oregon. We just don't know where it's going to be.
That's cute.
Yeah. Well, you never know.
Hey, you guys, that means that we're doing okay for global warming so far.
No, it doesn't.
Even though eventually we're all gonna die.
Okay, so let's have a look at this. If we want to, I don't even really want to spend the time with the graphic one, with it, solving graphically. What would we do to solve this graphically? There's only one thing I want to point out to you here, and you're using your graphing calculator to do this. This is what I call solving into the calculator, right? If you go to the y equals button, what do you, the one defining characteristic here is that it's always y equals. Well, what if the equation isn't written as y equals? What do you have to do? Yeah, you got to move everything to the other side, right? Okay, let's put all the phones away, please. You guys got to get this. This is going to, otherwise you're going to be struggling. So if we want to take this first equation and put this into y1, what are the steps I would do to get the y by itself? Okay, I'm going to move, I could move the y and move the 3. That would be probably the easiest way, right? Move the y to the right and move the 3 to the left. That's fine. I can do that. Or I could subtract 2x. And what I've always kind of taught people to do in Algebra 2, like when we're solving linear systems, and we haven't really gotten to this yet. We're going to get into more of this here, this chapter. But what if we had something like this? What if we had, let's say, something in standard form, like 3x minus 4y equals 7? How could I conveniently put that into the calculator? I'm going to put this in like as y1. Wouldn't I just subtract this term to this side and divide the whole thing by -4? Right, does everybody agree? So there's, on your calculator, you can always start by, what I would always tell people to do when you're solving into the calculator is, if you've got y1 equals, start with a bracket, right? Unless you just can see, obviously you don't need it. Whatever's already on the right side goes there. You're going to subtract away the other term and then divide by whatever the coefficient is every time. And it always works, right? So if we were to follow that, kind of just that pattern with this one, we would just go open up a set of parentheses. You already started with a 3 on the right side. We're going to subtract a 2x and divide by -1, right? Now we isolated the y onto that side. What about this one over here? Well, this one, all you got to do is just add 6, right? So we would just get 2 times the quantity x plus 1 squared minus 6. Okay, so we got everything into the calculator. Now comes the part where I think people still, this is probably the hardest part actually, is getting it to look right on the calculator. What are we going to do? What do you think? Ooh. What am I going to do to get this thing to look right on the calculator? If I just hit graph, I don't know what the window's sized at. So and there's no one idea here, but I mean, we'll just talk about how you could approach this. Okay, we could go zoom standard. Yeah, we could just try zoom standard. Why not? So zoom 6, zoom standard. There's the line. And we got lucky. It worked, right? So if I want to find the solutions to this linear system that we just solved, and there it is, right? We're solving that linear system. What are we? We're just trying to find the values of x and y that make both equations true, right? And we've talked a little bit about this before. We've done some examples like this. That just means where they intersect, right? Okay. If I graph the two functions, I'm looking for the intersections, then all I'd have to do is just go second calc intersect, and then yeah, y1 and y2 are the curves I want to intersect, and then make a guess. Well, I don't know, that looks like trace over close to that one right there. There's one intersection, right? It's a decimal. It's not going to be exact. This is going to be a numerical thing. And then yeah, I can just repeat the process and find this other one. No big deal, right? You guys have had some practice with that. Okay, how could we do this? Let's just talk briefly here. And really, this section is kind of a non-section for you guys. You're so good at algebra, this won't be hard at all. How could I solve this linear system non-graphically? What are my options? What do you think?
Put y on one side and plug whatever on the other side in y.
Okay, so we could solve by substitution, right? That would work. I could, for example, in this top equation, I could just solve for, I'd probably want to solve for y, wouldn't I? And you kind of want to think a little bit strategically with this. And like in calculus, when we do stuff like this, sometimes it pays off to spend 3 or 4 minutes just thinking about what's going to make the calculus easier, right, if I make a substitution. I don't really want to substitute a bunch of stuff in here for x and then have to square it out, do I? Right? I'd rather be able to substitute for y where it's a linear substitution. So one strategy, and that's fine, would just be isolate y, and that's just going to give us 3x minus 7 when all the dust settles if I just do a few steps. Everybody agree? Okay, whenever you make a substitution equation, I always think it's a good idea to put a box around it because you usually come back to it to evaluate that variable. And then I would just substitute that in for y. And let's go ahead and do this. And if I do that, what did I accomplish by substituting? I eliminated a variable, didn't I? Right? I eliminated y in favor of x, and so now I just only have x's in there. And so we'd end up with 3x minus 7 plus 4 equals 2 times x plus 5 squared, right? And how many different kinds of variables? Well, 1. So we should be able to solve this then, right, by just doing some algebra. So let's look at the algebra. What are we going to get? If I combine like terms, 3x minus 3 equals 2 times x plus 5 squared. Suggestions? I don't have a single x I can point at, so clearly I can't isolate x. But I can't really do much of anything with it in that form, can I? What do you think?
Distribute the two.
Okay, I can't distribute the 2 first, right? Because I've got a square, and I want to make sure everybody understands why. When you want to organize the operations you're going to do to solve this thing, there's only 2 directions you can go on the order of operations tree. Right, we've got, if we're isolating, we know that we go in this direction. If we're simplifying, we go in this direction. And we're always doing one or the other, right? Well, if I'm doing something like distributing the 2, the idea is trying to turn this into an expression where I can add up like terms, I'm thinking, right? Square this out, distribute the 2. Which direction am I going? I'm going down, right? That's simplifying. It's not isolating, it's simplifying. So I have to follow this order of operations, the top-down order of operations. So there's two things I would have to do here on this side. I would have to deal with the exponent by multiplying it out, and I would have to distribute the two, which would be multiplication. Which would have to come first? The exponent. I would have to expand this out, wouldn't I? So this would equal 2 times, if I do that, what am I going to get if I multiply that out? X squared plus 10x. Good. Now, we're getting someplace. Now, if I distribute the 2, I should be able to, take these terms on the left and move them over to the right and put this into standard form. And then I've just got a quadratic equation in standard form, right? We can deal with that. What are my options if I have a quadratic equation in standard form? I could complete the square. What else could I do? Quadratic formula. If it's really easy to do, I could even factor, but that's only if it's easy, right? Otherwise, it's not worth even trying. Okay, does that make sense? Okay? Oh man, I wish I had just like 3 more minutes. Okay, we get through most of it.